Hello and welcome to day 15 of learning ML from chatgpt. So let's get started. So yesterday we learned about sentiment and analysis using the IMBD movie ratings dataset. So here we use a sequential model with an embedded model, which converts we saw indices into dense vectors, which is part of what's needed for the recurrent neural networks. It carries memory with it, so we use the LSTM, long short-term memory. And so recurrent neural networks, just to recap, they're mainly for data sets. The order in which a specific data point is matters. Like, for example, in stock prices, it matters because it's in time, and there are lots of other useful parts of this. And then we had a dense layer with activation function of sigmoid. If you remember, that gives this one's binary, so it gives the probability for it to be positive sentiment, probability for it to be negative sentiment. So let's see what we've got in store for today's lesson. Okay, so we're day 15, week 3. Attention. Okay, so we're week 3, so advanced topics in deep learning. Day 15, attention mechanisms and transformers. Attention mechanism, introduction to transformers. Basic transformer model implementation, assignment, use a transformer model for machine learning. No, for machine translation. Okay, I actually don't know what today's lesson is about, so let's get started. So please give me day 15 lesson. Oh no. Wait. Hopefully, the problem is now it's such a long thread of chat, that it takes a while for it to load. Okay, so day 15, attention mechanisms and transformers. So an attention mechanism is a model. No, attention mechanism allows a model to focus on specific parts of the input sequence when making decisions, improving performance on tasks like translation, text summarization, and question answering. Intuition. Attention helps the model pay attention to relevant parts of the input rather than processing all parts equally. So assume this is a bit like the L1 regularization, where some features, their weight became 0. So that means they had no effect on the other neurons in the neural network. Okay, self-attention, a key part of transformers. Self-attention allows a model to relate different positions in a sequence to better understand context. What? So, self-attention allows a model to relate different positions in a sequence. Okay, so I assume this is if you got several features, like say feature X and feature Y. Self-attention could see that there's a link between them to better understand context, as it says here. Introduction to transformers. Transformers are state-of-the-art models in natural language processing that rely on self-attention mechanisms to handle sequences of data. They improve over traditional models by removing the need for recurrence and convolutions. Okay, key components of transformers. Encoder, decoder structure. Transformer has 2 parts, an encoder that processes the input sequence and a decoder that generates the output sequence. Okay, multi-head self-attention. This model performs multiple attention operations in parallel, allowing it to capture different types of relationships in the data. Is this supposed to be multi-thread instead of multi-head? I'm not sure. Positional encoding. Since transformers process sequences in parallel, unlike RNNs, positional encodings are added to capture the order of data. Code example. Basic transformer model implementation for machine translation. Here we'll implement a basic transformer for machine translation using TensorFlow. Okay, so positional encoding. So if we go back to this. Since Since transformers process sequences in parallel, positional encodings are added to capture the order of the data. Scale dot product attention. And then we're creating class multi-head attention. We're initializing the model, so we're inheriting it from Keras layers layer. It's the model, so we're just assigning them. We're asserting that the D model is divisible by num heads, and there's no remainder. Split heads, transformer. Wow, this is a lot of code. So for now, I'm just going to I'm not really going to go into the code too much. I'm just going to just understand the concept. Use a pre-trained transformer to build one from scratch. Use a machine translating dataset, e.g. English to French. Fine-tune the model on the dataset and evaluate its performance. I'm just going to please. Wait, I'm just going to get rid of this keyboard because it's been a little bit of the way. Okay. Hang on a minute. Sorry. Okay. Okay. I'm just going to ask it. Please implement this based off of this code. I'm just going to also check what tomorrow's lesson is and see if we're following on from this topic. Generative models. Oh! Generate synthetic images using a GAN. Okay. I don't think ChatGPT did the best explanation of this, to be honest. Because it's talking about like self-attention, how it can draw conclusions from similar data, but yeah. Okay, I'll wait for this to output a result. Let's see. I also want to know, does Python have an inbuilt transformers library, or does most of it have to be implemented from scratch? Oh, still generating. Okay, copy the code. Let's see if this runs. Problem is we're getting even like more complex models, so it will take even longer to execute. Okay, back to ChatGPT. Will it run? Okay, we're just loading the dataset at the minute. French to English, no, English to French. One. Okay, so you're getting the data there, and then the tokenizer for English. Sorry. So tokenizer for English is Okay, so we're just having them as the same, but training examples. I don't know by. Yeah, so PT. Okay, yeah, we can see it's just a bit English and French. The max length is 40. Okay, we're encoding it, and then as soon as this TensorFlow encode, this is going to take a while. Photo max length, positional encoding. Okay, I'm just going to assume this is just right. I'm going to ask chatgpt to just give a really simple explanation, concept explanation. Okay, so there are pre-built transformer models. Sentence, how are you? Okay, yeah, so that's much easier, but then obviously you don't have the performance benefits of like the customization abilities. Okay, hugging faces transformers. I see. I'm also going to copy this just below. So hugging face transformers pre-built model. Okay, I'm also going to run that after. So now I'm just going to copy paste. So please give me a really simple explanation of this code. We just explain the concepts, but not the code itself. Make it really simple. Okay. Let's see. Oh, it's not generating. How far are we in this? Oh, we're not even online. Where are we? So we're still just. Oh, it's gonna take a while. Oof. Okay, let's see what ChatGPT has generated. If it even has generated something. Regenerate. Okay. This code implements a transformer model, a type of deep learning model used for tasks like translation and text generation. It's a simple breakdown of the main concepts. Positional encoding. Transformers don't process data sequentially like RNNs. Okay. Positional encoding helps the model understand the order of the words in a sentence by adding information about the position of each word. Okay. Scale dot product attention. This is the core idea behind transformers. The model looks at all words in a sentence and decides which words to pay attention to when processing each word. This mechanism helps the model focus on the important parts of the input. Multi-head attention. Instead of looking at just one way to focus on important words, multi-head attention uses multiple ways or heads to capture different aspects of the relationships between words. This makes the model better at understanding the meaning of the input. Transformer layer. This is a building block of the transformer. It combines the multi-head attention mechanism with other operations to help the model learn complex relationships between words and phrases. Feed-forward network. After attention, the data is passed through a simple neural network to process the information further and make predictions. Layer normalization. This step helps stabilize and speed up the training of the model by normalizing the outputs of each layer, making sure that the values aren't too big or too small. Embedding. The words in the input sequence are converted into numerical format word embedding so that the model can work with them. Transformer model. The model consists of multiple transformer layers stacked together. It processes the input at a sentence and predicts the output, translating a sentence from English to French. Okay, so my basic understanding of this is that with a transformer model, you have something called self-attention, and unlike RNNs, which pay attention to the like order of them, like self-attention, it figures out which words are most important. Like, for instance, it would be like maybe it would find a structure like in like English sentences, and then it can be transferred into French, so I can see the relationship between them. And this like self-attention is the way of finding the most important ones, and also it just looks at the position of the word for it. So after simple neural network. Okay, so feed-forward network is like the additional bit of thing that we use. Stabilize, speed up. Okay. Yeah. So this transform model uses attention to focus on the important words in a sentence and multiple layers to learn how to translate and process language effectively. Okay. This is cool. So this scaled dot product is how we figure out the attention. And then multi-head attention is like we're looking at multiple different like relationships between the data. Position encoding. Okay. So yeah, I'm just gonna see if this is run. Oh, runtime discount. Yeah, it stopped after 4 minutes. So yeah, I think I'm going to end the video here. So thank you for watching, and I'll see you in the next video. Goodbye.